Hello and welcome to the first dose of Daily Data Science. I'm very excited to welcome you all to this new playlist that I'm planning to create over the next year. Without further ado, let's get started. So you must be wondering first, who am I, right? Let me have a quick recap about background and we'll then get started. So I'm Anant. I completed my high school from the Doon School, which is a residential school. I was there for about 4 years where I really learned a lot of things. Went on to do my bachelor's degree from IIT Kharagpur. Then enrolled for a PhD at the University of Minnesota, but dropped out because I wanted to work in the industry. And this was about at the time when data science was really taking off. And I started working in the industry after this, worked as a lead data scientist for a couple of years before going to do my MBA from Indian School of Business, Hyderabad. I currently manage a team of data scientists, and I started out as a data scientist in San Francisco. I was also a researcher at NU Singapore and UNSW Sydney, Lund University, Sweden, among others. I've played squash at the national level. I'm also a fingerstyle guitarist, and I have played chess as well. Now, why did I decide to do this daily series, right? And that too for free. See, data science is ubiquitous across every industry. Whatever industry you're working in, it is very likely that this will be very useful to you. And we will just see shortly why. Quality data science education is currently not very accessible, right? So data science education is definitely accessible where you can see blogs, you can see online courses, but there is a challenge there, right? The quality sometimes shifts towards more theoretical, sometimes it's towards more practical, so you don't get a right balance, and it's difficult to follow large, long online courses on your own, right? So the goal with this series is that you get 15 minutes bite-sized content every day, which if you religiously practice and you listen to, it will really make you very familiar with data science. And it's kind of a technological literacy that you should have in today's age, right? It's just like financial literacy. And lastly, I'm very passionate about teaching. I have taught more than 600 students over the last 2 years through my personal masterclasses and over other platforms as well. Now, let's come to understanding data science. And today's topic is going to be understanding data science, like what is data science field all about? And then why should you actually learn this, right? What is its relevance to you, right? First, let's understand what is data science. So if you look at this picture, this was an image which was published in The Economist magazine about 10 years back, right? And it was very popular at that time. You can see that these are all oil tankers, right? And oil is very lucrative. Now, there are these large tech companies' names on top of these oil tankers, right? So this is essentially saying that data is the new oil, right? So as lucrative as oil has been, data is as lucrative, right? Only if you mine it the right way. And that's what we are going to learn in this course. How do you mine and learn from data in the right way? All right. You must have also heard about a news from OpenAI last year, right? Does this name ring a bell? So OpenAI is that company which actually created ChatGPT, right? Which is now a household name, right? So even if you're non-technical, you must have heard about ChatGPT. You can ask ChatGPT to write a poem for you. You can ask it to write marketing messages for you, right? More lately, you can also ask it to do data analysis. That capability is available in GPT-4, right? You input a CSV file and you can ask it to do data analysis, and it automatically does that as well, to a reasonably good degree. So OpenAI had launched ChatGPT last year, and ChatGPT is what we call a large language model, right? Don't worry about this term because we will cover this in a lot of depth going forward. But essentially, it is a data science model, right? And it is within the field of data science. Now, let's understand what exactly do we mean when we say that this is data science or we are doing data science, right? Is everything related to data under data science? Like where does the distinction start? So let's go over certain definitions which were very popular a few years back. And these were the most popular definitions on Twitter. The first one is a data scientist is a statistician, right? Just someone who is doing statistics and statistical analysis, but who is living in San Francisco. Because San Francisco is Silicon Valley, right? The home of the technological innovation around the world. And any person who's doing statistics and who lives in San Francisco was thought to be a data scientist around that time. And this is not accurate, right? But this was very popular. The second definition which was popular is data science is statistics on an advanced compute machine like the MacBook, right? So if you're performing simple or even complex statistical analysis on a MacBook, it was termed data science as per popular Twitter definitions. But this is also not completely correct. And then the third definition comes the most close to the actual meaning. A data scientist is someone who is better at statistics than any software engineer and better at software engineering than any statistician. So this definition is essentially saying that a data scientist should know more statistics than a computer engineer or a software engineer, and more software engineering than a statistician. So he should have a reasonably good amount of knowledge about statistics and software engineering. But there is one key element that is left out of this definition, right? Now you might think, what is that? Aren't data scientists just building softwares and working on based of the data? And data analysis basically means statistical analysis. Well, you're almost there. The reason being, data science is a combination not only of computer science and math and statistics, right? It has a third dimension where you need to understand the business or the domain as well, right? And this is where data science not only becomes a science, it becomes an art as well, right? How do you build a computer system or a computer program which has a strong mathematical and statistical background to it, right? Every kind of a rigorous analysis has been done, but it makes sense from a business point of view, right? And think about applications like you're forecasting the demand of your product, right? Or you're deciding the pricing of your product based on the competitive landscape, or you're trying to manage the product's inventory, right? Or you're trying to do other things, right? Like quality control, visual inspection, and so on. So you need to have a certain amount of business expertise so that you can put the theory in context. And this will become very clear when we talk more about the different use cases that data science is actually able to solve. Right now, our focus is understanding what is data science. So let's come back to it. Computer science, right, and maths and statistics, when you combine these form the field of machine learning, right? Machine learning is based on a strong mathematical background, and essentially you require software engineering skills to perform machine learning. But you don't require any business expertise as such, right? Technically speaking. If you combine computer science and business expertise, right? Think about your traditional software programs. Whenever you're building software engineering applications, right? Like you have an application such as Swiggy, for example, or you have Zomato, for example. Now, that is a software application which is allowing you to browse through different products of food and order food, and also track where the food is and when it is going to be probably delivered. So it is a computer application, right? And it requires a business or a domain expertise, right? So for different food items, you will need different descriptions about what ingredients go in, right? And they need to be bucketed into certain categories and so on, right? This is a very simple example. So this is where traditional software sits in. Now, obviously, Swiggy and Zomato also do data analytics, but they do that behind the hood. It's not happening like it's not the main value proposition to the end user, right? So that is the field of traditional software. And then if you combine maths and statistics with business and domain expertise, this is what data analysts usually have been doing, right? You're using simple mathematical and statistical concepts to understand the data, where you are. Now, data science is a combination of computer science, maths and statistics, and business expertise. So it is combining, it's taking something from each of these three domains, and you are doing machine learning, you're building software applications, and you're also doing data analysis, right? And this is where the data science unicorn actually sits. And it's part of the reason why data science is so difficult to learn and even more difficult to actually do it in real life, right? Learning is just one part of the journey. When you apply it, then you figure out the different complexities that you face as a practical or a real life data scientist. Now, let's understand what are the different kinds of data science that can be done, right? So we can bucket data science into 4 different categories. And loosely speaking, data science is same as data analytics. Data analytics is same as just analytics, right? So because analytics are always based on data, right? So if you're talking about analytics maturity here, this basically means data science maturity of organizations, right? And this is the Gartner analytic ascendancy model. It's a very popular model which details out where organizations are in their data literacy and their in the way that they are taking value out of the data. And this has been sourced from sketchplanations, right? Now, the first simplest kind of analytics is what is called a descriptive analytics. You're simply describing what has happened in the past, right? How many products did I sell today, right? That's a question that you can answer using descriptive analytics. You're probably looking at scatter plots, you're looking at certain visualizations, trying to understand the historical data, and you're describing it, right? Probably you're also doing statistical analysis, like you're telling the mean, median, mode of certain variables. That also falls in simple descriptive analytics. Now that you have the power of hindsight and you see what has happened, the next step of analytics, right, the second stage, is why did that particular instance happen, or why did that particular event happen? That is the area of diagnostic analytics. And statistics actually helps us do most of this diagnostic analytics. For example, in this case, if we ask, how does weather affect sales, right? We are looking at historical weather information, we are looking at historical sales information, and we are observing a certain phenomena that sales of ice creams, let's say, goes up when it is winters, when it is summers, and it goes down when it is winters. We observe this simple phenomena in the data. That's descriptive analytics. Now, diagnostic would mean, how does that affect, right? How does the sale, the season affect the sale of ice creams, right? And if you just look at the data historically, you would be able to make sense of it. But theoretically speaking, rigorously or statistically, you will not be able to say that the season affects or it causes the ice cream sales to go up. You can definitely say that there is a correlation, but is there a causation or not? That is the field of diagnostic analytics. And this is a simple example that I'm giving just to show you the difference between diagnostic and descriptive, right? And for doing this causation analysis, there'll be advanced statistical analysis that you need to do. And this is where you're now coming into insight. You're getting certain insights out of your historical data. The third step of analytics is predictive analytics. Now that you have seen what has happened in the past and you have diagnosed why it has happened, can you predict anything about the future? That when the next time winter comes, how much are the ice cream sales going to dip? Right? Can you actually quantify that? That is the field of predictive analytics. And here is where you're getting into the really fascinating field of machine learning as well, right? So predictive analytics, think about it in today's age as a very large area of which is machine learning. What will I sell the next time winter comes, right? Looking at what has actually happened and what is the actual relationships, how will that affect my future sales? And finally, the ultimate gold standard, right, of analytics is prescriptive analytics. Okay, so what you know is this has happened in the past. I know why this has happened. This is what's going to happen in the future if the regular conditions apply. Prescriptive analytics goes one step further. It says, how do I actually optimize or maximize my sales in the next winter? Right? So my sales are going to dip. But do I know of certain products in the ice cream sector, ice cream category itself, where I can push more sales looking at the historical data? Or do I know what are the different cities in which ice cream sales do not dip as much? So all of these kind of trade-offs you can make, and you can prescribe a particular solution to the company that this is what you should do. So you're prescribing, but how are you actually prescribing? You are optimizing behind the hood. So prescriptive analytics is the field of optimization. How do you actually prescribe? You're optimizing for the different conditions that can be possible, and you're prescribing the best solution out there, right? And this is the gold standard because it's going one step further. You're not only doing predictions, you're doing prescriptions of what you should do so that your value is maximized, right? So what we have covered so far, just as a quick recap, is we have understood what is the field of data science. We have understood the three verticals of what defines data science. And we have looked at the four different kinds of analytics that are possible, starting from the basic of descriptive, going to diagnostic, going to predictive, and then finally going to prescriptive. And organizations are at different levels of these analytics maturities. Now, we have talked about what is data science, right? Now, if you're interested in data science already, well and good. But if you're still thinking, why should I actually put in so much effort, right, every night at 10 p.m. or every morning at 11:30 a.m. Central Time to learn data science, right? What is the value proposition? I'm a marketing professional, probably I'm a consultant, right? It's too technical for me, right? Why should I actually care? Now, let me show you a quick graphic. And this is talking about the build of Fortune 500 companies with the most data scientists, right? So I've gone to datagrom.com, right? And this website has a very nice distribution of the different sectors in which data science is applied by the volume. So technology obviously comes on top with 44%, and a lot of technology companies are doing data science, which is expected. Financial companies also come because these are data heavy companies. So definitely they would also be doing a lot of data science. Retailing companies, right? Like e-commerce companies like Amazon, Expedia, and so on also do a lot of data science. And they do a lot of recommendations. They do a lot of A/B testing, which is like, how should I design my website so that my click-through rate is optimized and so on. Healthcare industry is also having a lot of data scientists. Remember, in healthcare, there is claim processing, right? If you're a health insurance company, you will do a lot of claim underwriting and a lot of claim processing as well. You will have a lot of customer service centers, which you can automate by the help of certain natural language processing tools as well, right? In healthcare, data science is also used to design new drugs, right? To improve and accelerate the process of drug discovery. So there also we can see a large amount of data scientists. Then we are coming to relatively smaller sectors like telecom, energy, industrials, right? Motor vehicles and parts, aerospace, and you can see a large variety of industries actually employ data scientists, right? Coming to even media and apparel, right? Even places like Nike, right? Ralph Lauren and all also employ data scientists. So this is just to show whatever industry you are part of, right? Whatever industry you're part of, data science is going to be super helpful to you. So take this effort, put 15 minutes every day. And while you will not probably become an expert in data science, you will be at a level where you can converse with anyone in the industry, in your own company, about data science, because you will know the fundamentals and you will know the thought process of what goes behind the hood of a data scientist. While you might not be actually working on it, right, in your day-to-day job, having this kind of a technical and even a non-technical mix background of data science is going to be very, very useful to you. So tomorrow we will talk about the different applications of data science. And stay tuned. See you tomorrow.